So going to the cloud just isn't simply, hey, I'm going to go to the cloud and migrate your applications to the cloud. There's a lot of things that you need to consider before migrating your applications to the cloud. So let's take a look at these and look at the scenarios and patterns and best practices about migrating your applications to the cloud. The first thing to consider is, what are your application migration strategies? How are you going to get your applications to the cloud? And what steps are you going to take to get your applications to the cloud? One of the things you need to consider is disposable computing, meaning if you don't need it, get rid of it, and breaking up your components into multiple components for scalability. That way, if you don't need a component, you can scale back when you're not using it. We'll also talk about dynamic scale, and we'll talk about shunting, and we'll also talk about prototyping, meaning do you take your entire application to the cloud, or do you create a proof of concept and move that to the cloud before you move your mission-critical applications to the cloud? So these are some of the things that we're going to talk about in this section. So we're all very excited about the cloud. The trick is to know what your system needs and how the cloud can help. Meaning, how do you take your current architecture and infrastructure, and how does that translate and map to the architecture and infrastructure of the cloud, of the Azure platform? And one of the things that you need to remember is that not everything has to or can live in the cloud. Meaning, one of the things that we see a lot is that everybody says, okay, I'm going to the cloud, and they move everything to the cloud, their database, their application, all the components, and then wonder why it failed. So not everything has to or can live in the cloud. The analysis must be done to determine what makes sense to move to the cloud. And you only want to move those components that can benefit from the cloud and the Windows Azure platform. The core term here is hybrid, or take an a la carte approach. Meaning, do I move all my infrastructure to the cloud, including my application and my database? Or from a hybrid approach, do I take a code near, code far scenario? Do I leave my code on-premise, and do I move my database to the cloud, or vice versa? So there's certain things you need to consider when taking a hybrid approach, and a hybrid approach is certainly a viable solution. And from an a la carte approach, you don't need to use every component of Azure. Only use what makes sense. So you may take and say, you may take your trade down the smorgasbord of the Windows Azure platform and say, okay, I only need roles, don't need queues, don't need tables, but I do need blobs, and I do need SQL Azure. It is certainly an a la carte approach, and that's the approach you need to take. And we call this software plus services, meaning we have our software and we're going to use our software, and what services are we going to use to deploy our software. And before you even begin, you need to take a look at your system portfolio. I'm going to ask, you have one, right? So the key is to look for your pain or distractions. What are your current pains in your on-premise solution? And find those pains and find the low-hanging fruit to solve those pains. The low-hanging fruit is really the quick hit things that you can do quickly and yet get rid of those pains. Let's take an example of a big pharmaceutical company. They have several applications, and they've built some and they've bought some. So they have their home-built applications from their HR system to their clinical trial, but they've also purchased some high-end packaged applications from an ERP and a CRM to their email. And they're spending a lot of money in hosting and running these applications, and so they want to determine how can the cloud solve some of their problems and solve some of their infrastructure pains. So this big pharmaceutical company is looking at their packaged applications and saying, okay, these are too costly to run myself, but they've also made too many customizations, so what do? They can't get rid of them, but how do they run them in an efficient manner? So what they've determined is they could put their ERP in a hosted solution, for example, in a hoster, and that'll solve some of their problems. But now they're asking from a CRM and email perspective, these are commodity services. We haven't customized those, and is it really cheaper for someone else to run these? So in this scenario, they said, yep, it does make sense for me to run those somewhere else. So they went back to the vendor and said, we're going to run these as a software as a service. So they went back to the vendor and said, hey, you run these, and that'll save us some money and cost on the infrastructure. They then looked at their home-built applications and basically decided that they can't afford to maintain their old HR applications. It's written in VB, and it would cost too much money to upgrade to .NET, for example. So what options do they have here? But at the same time, due to regulatory issues, they can't really store this information off-premise. So what they decided to do in that case is to essentially scrap their home-built application and purchase, because at that point it makes sense to purchase a packaged HR application. But they're then asking themselves, well, they wish they had access to a cheaper compute and storage when they need it. They have a lot of clinical trial applications, some molecule research applications. These applications store a lot of data, and it's costing them a lot of money to store that information on-premise, and those files and those blobs on-premise. So what options do they have? So it really makes sense to move that application and those files to the cloud. Then they look at their clinical trial application and decide that this is where they want to spend their IT resources, because they can better this application and still determine whether they want to run this in the cloud, where they want to host this, and can they even still use this as a platform as a service application. So when you're looking at moving to the cloud, there really are only two reasons why you want to move to the cloud. The first one is to improve the bottom line. How much money can we save by moving to the cloud? And the second reason is to improve strategy. This stems from the need to be more efficient, to be able to deliver to your clients more efficiently, and essentially provide better direction and have a better overall strategy for developing and deploying applications. However, even though you're looking to improve your bottom line, and even though you're looking to improve your overall strategy, the first thing you need to do is determine and look at the return on investment for going into the cloud. So things to consider are, what are your current hosting costs? How much does it cost to host this on-premise or another hosting vendor? What are your current staff costs? How much are you paying your staff to manage and maintain your web servers, your SQL clusters, and those types of infrastructure? What are you paying for cooling and power and space? How much are you paying for rent at the hosting center? And what's your overall cost for cooling, power, and space? What are your migration costs? What is really going to cost you to migrate from on-premise to the cloud? And lastly, from a licensing perspective, what are you paying in licenses on-premise? This includes your operating system licenses and your SQL Server licenses and any other licenses that you may pay on a yearly basis. So to determine these, Microsoft has offered up a TCO calculator to help you understand and determine these costs and provide you a return on investment ballpark as to how much you can save by going to the cloud. Now, even though you might have gone through all those steps, you still need a migration strategy for going to the cloud. So what are the things to consider? Well, how about identity? Meaning, even though you're going to the cloud, what additional vendors do you work with? What additional customers do you work with? And how do you determine who you're communicating with and who's coming in? So identifying those players that you're communicating with. You also need to consider backups. From a SQL Azure perspective, SQL Azure does not provide us a SQL backup strategy as we know it. You do have the ability to do an as copy of and create a second database. But from a backup perspective and backing up to a file or backing up to a device, that's not there yet. So from a backup strategy, how do we solve that problem? And then from a data migration strategy, how do we get our data and our applications from on-premise to the cloud, to SQL Azure? So from a migration strategy, how do we really migrate? And we really have three paths to choose from. On one side, we can just do the splot method, which means let's just take everything we have, the database, the application, all the components, and just throw it up into the cloud and see if it sticks, right? We could do that, or we could do the vNext equals vCloud scenario, meaning we're always waiting for the next version of the greatest cloud technology to help us solve our migration problems, right? We could do that. Or we could do a hybrid approach, which is the other end of the splot method, meaning let's take a phased approach or a hybrid approach in migrating. For example, maybe we migrate just our application and keep our database on-premise, or maybe we even migrate just a portion of our application, or maybe we migrate just a portion of our data. So you really have 3 different paths to choose from, and it all depends on what your requirements are and what you're trying to get out of the cloud. So common scenarios for migrating, we need to look at the dynamic scale reduced cost concept. If we can dynamically scale instead of spinning up multiple instances, let's dynamically scale to reduce our costs. So remember that Azure is all about elasticity, paying for what we use. So if we can dynamically scale up and down, this will save us cost in the long run because we're only paying for what we use. And this leads really to disposable computing. If we're not using something, get rid of it. If we don't need an instance, shut it down. And then there's the concept of load shunting. Load shunting really comes from the context of electricity, the act of connecting one device to the terminals of another so that the current is divided between 2 devices in proportion to the respective admittances, meaning how do we distribute the load from one to the other, right? And this also applies to Azure. So shunting happens at the application level. This is when access load on the system is redirected from a normal infrastructure to infrastructure running in the cloud during a spike in load. For example, when the holidays come. The e-commerce site runs normally on 3 servers, but when there's a sale, excess capacity over the 3 servers capacity is directed to some servers in the cloud. Windows Azure is really a great resource for startups and proof of concepts. On the vertical line, we have our IT capacity, and on the horizontal line, we have time. And really, if we're trying to get a business started or trying to do a proof of concept quickly, our barrier to innovation, it really is minimal. The reduction of our initial investment can be small. We don't have to go buy a whole set of servers to support our infrastructure and to support the spikes that we may have when our load increases. So really, our load time is low. We have a reduction of oversupply, and we have no undersupply. We can spin instances up and down based on our load. When working in the cloud, one of the things that we do need to consider is the data in motion. So let's say on-premise we have our database and our system, and we have our firewall, and someone might come in and send us some data, and it accepts. But another merchant may send us some data, and it's rejected for whatever reason. But how do we solve this in the cloud? Well, in the cloud, we can migrate some of our components to the cloud. We may not migrate our application to the cloud, but we can certainly migrate our database and implement some of the Azure storage components, such as queues, to the cloud, so that our user can send messages to the queue as many times as they want, and then route those to our system for processing. So from a data movement standpoint, we should highly consider using the cloud components. We also need to look at mass storage. Let's say your application stores a lot of documents and binary objects either in the database or on a local storage somewhere for use. And so you have a lot of bandwidth, not only from HTML, but also from documents and images and things like that, taking up a lot of bandwidth. A lot of this information can be moved to the cloud, meaning we could use Azure Blobs, move those binary objects to cloud storage, and utilize Microsoft's bandwidth to provide better upload and download capabilities to our application. Another concept to consider when working with databases is the concept of multi-tenant. This allows us to reduce management costs, has very little impact on the re-engineering of our data tier, and really improves scaling and high availability options. For example, we may have a scenario where we have an application with its customizations and a database with fixed schema. We can fix that by breaking the database into multiple databases, and in this scenario, storing customer 1's data in database 1, customer 2's data in database 2, customers 3 data in database 3, and so on. But we can also do a multi-tenant scenario where we still have the application and the customizations, but we're still using a single database, but breaking that database into a multi-tenant scenario where our customers are broken up by schema, for example. So in this case, lower management costs because we're still only dealing with one database and not multiple databases and not multiple disks. We don't have to re-engineer our data tier, and because we're in a multi-tenant scenario, we've really improved our scaling and our high availability options. So we've decided to move to the cloud. How do we move to the cloud? When we're going to the cloud, we really need to focus on moving to the cloud in pieces. And to do that, you need to leverage the services available in the cloud. And one of the ways to do that is to decompose your system into pieces, leading to flexibility, meaning if you have one service that does everything, meaning data layer and your security and components like that, you might consider breaking those up, decomposing those components into different systems to lead to flexibility. So by decomposing your components, you can get to a more granular layer. Now, many applications need to communicate with either other applications or communicate with other vendors or other customers. So how do you do this in a secure manner, and how do you do this in an efficient manner? And the solution to do that is to use a service bus. And a service bus really is designed for scale. And it leads to, by using a service bus leads to really all the ability type of things, such as scalability, flexibility, those type of abilities. And it actually also forces you somewhat to decouple. We can't stress this enough that decoupling is important. Decouple and decouple. Break those components out into separate components. Now let's take a look at things from the data side. We've talked about it a little bit. Let's take a little deeper look. We need to consider when moving to Azure, you need to consider your data model. This includes your on-premise data, and how does that translate to SQL Azure? Does some of your on-premise data make sense to go into Windows Azure tables? For example, do you have historical data that really isn't accessed much, but is taking a lot of space in an on-premise table? Well, you can actually move that data into Azure tables for a much cheaper storage solution. One of the benefits the cloud gives us is elasticity, or the ability to scale up and down as we need to. So in order for us to take advantage of this benefit, our solutions must be designed to be able to scale out easily. Adding more instances to a web role that hosts our website so we can handle more concurrent users is an example of this. However, if our current on-premise solution relies on in-memory state management, we'll have to modify that before we push it to the cloud. So we need to consider these things as we go to the cloud. Also, have a plan in place in regards to how and when you will scale your instances in the cloud. If you have a predictable usage pattern, then plan to scale accordingly. But what if you don't have predictable usages? Make sure to include metrics gathering so you aren't caught unaware that your application is getting overloaded. Have a known plan in place on who has the authority to scale up instances and bring them back down. And part of the scalability options is the ability to choose from several sizes of VMs. You can choose from extra small, small, medium, large, and extra large. Each increment up, except from extra small to small, really roughly doubles the resources in terms of CPU, RAM, and storage location. The size you choose is going to depend on what your application requires, and the trick is to choose the smallest size that will still get the job done so you can scale by the smallest increment that you can get away with. Let's say that you have a website that you want to move to Azure, and you decide that you want each instance to be able to serve as much throughput as possible so you can select an extra large instance. More cores and RAM means more horsepower, right? Well, the VM size is configured in the service definition file for each role, so the cost of 4 small VMs is the same as a single extra large VM. But if you have set your VM size to extra large and you are seeing your need to increase your instance count because your site just got very popular, then you'll be increasing your cost by another extra large VM size when perhaps just an extra single small VM would have done the trick. Again, select the smallest size you can get away with that still gets the job done. And by the way, changing the VM size requires a redeploy, whereas just adjusting the instance count does not. Another reason to look at sizes is not only cost, but also about effect of failure on the system. If you have large instances, then a failure in one of them affects more of your throughput or processing capability. And in some cases, you'll find that portions of your solution need to be able to scale at a different rate than others. These more scalable features or components need to be abstracted into something that can easily be set at its own worker or web role so that you have the ability to scale it as necessary. But don't forget that scaling out isn't the only option in the cloud. For serious number crunching, you may get more value from scaling up your virtual machine size. Now let's take a few minutes and look at the Azure data market. The Azure data market is built on Windows Azure and SQL Azure, and as such, the data market uses web roles to provide services, billing, security, and monitoring as well as the website. But the data market connects to data owned by content providers and is stored in either SQL Azure or third-party clouds such as web services or databases. As you start migrating into Azure, there are really generally two phases. There's the just in the cloud, meaning just do the minimum to move the application to the cloud using features that ease legacy hosting, or cloud-powered, meaning we're going to take advantage of all the features and all the components in the cloud and refactor our application to take advantage of these features. Now, you might be looking at these and going, well, which is the best? You might be saying, well, obviously the cloud-powered is the best, but it may or may not be. It really depends on your architecture and the application that you want to migrate to the cloud. So in essence, do your homework first. Figure out what's your current architecture and infrastructure and what components of that application would do well in the cloud. And in doing so, there are certain considerations. First and foremost, where should my data live? Should I keep it on-premise or can I move it to SQL Azure? And that all depends on what does your data contain. Is there certain data that doesn't make sense to go into SQL Azure? Maybe you don't want to put credit card numbers or social security numbers in the cloud. So really you have to look at your data and say, where should that data live, or where can that data live? And then what are the costs? What is it going to cost me to move my data and or my application to the cloud? And we talked earlier about a TCO calculator that can help you figure that cost out. You also need to look at code compatibility. Are you using .NET? Are you using VB6? Are you using a Windows Forms application? Are you using an ASP.NET application? Windows Azure supports Java, PHP, Python, but if you're using Power Builder, for example, well, that isn't supported in the cloud. So what are your applications developed in? And obviously, one of the biggest things that people talk about when deciding to go about the cloud is security. When designing applications for the cloud, you really should design with security in mind. The next few slides will look at typical design challenges that you might face, traditional defenses you'll encounter, as well as the defenses that you need to implement in your cloud applications, and some design patterns for developing ASP.NET applications. So using this visual model concept above, we can evaluate cloud applications hosting both the application and data layers in the managed infrastructure, which in this case is the cloud. The key takeaway here is that with managed infrastructure, we can remove checks from our list because they are items handled by the managed infrastructure. For example, a Windows Azure application will not have permissions to create user accounts or elevate privileges. This alleviates the need to manage accounts at the host level. There are also no considerations in securing the network, as this is handled by the service provider. So, architects and developers should focus on security measures at the application level, which becomes even more important in this kind of environment. From a security perspective, the fundamental difference when moving to a platform as a service, like Azure, is that a large part of the stack is now under the control of the service provider. At the data center layer, the developer can specify how many instances Azure will deploy for which role in the application. This gives the developer a degree of control of the infrastructure available to cope with high level of demands. At the platform layer, Azure provides developers the choice of which level of trust the .NET code will run, using the .NET Code Access Security feature. The Azure platform also provides interfaces for implementing claims-based authentication and authorization, a platform for really collecting and persisting audit logging, and mechanisms to secure access to the data store. However, at the application layer, the developer has much more control of the security architecture of their application, and they are the ones responsible for developing code that follows the security best practices that will mitigate traditional web security threats like SQL injection and cross-site scripting. Applications should use the threat mitigations provided by the Azure platform, which may be in some ways different than the ones available in traditional platforms. So, how do we map traditional defenses to the cloud? The security landscape for cloud-based web services is substantially different from traditional on-premise web services in terms of mitigating tools and technologies. Some of the mitigations available in traditional on-premise security architectures translate to the Azure platform and the cloud. The key takeaway is that despite some of the protections that moving to the cloud may offer, developers are still responsible for writing good code, and they are still responsible for the security of their applications when dealing with threats to the web service code itself. So let's look at some of the ASP.NET design patterns that will help us when deploying our applications to the cloud. This scenario represents the most basic implementation of authentication in an ASP.NET website by using the ASP.NET table-based membership provider and roles provider system, and also Windows Azure Storage. This pattern is primarily used by applications who have an existing solution based on ASP.NET membership system, and whose authorization needs do not extend beyond simple usernames and groups roles. And along with that, the metering expenditures are based on total storage size utilized, not on the number of transactions. So in this pattern, the user provides its credentials, and in this case a username and password, over SSL to a web form, and the application uses the table storage membership provider to authenticate the user to an Azure table. Access to the Windows Azure Storage in this scenario is controlled through the storage access key that the application possesses. Authorization is then done in the application logic using the ASP.NET table storage role provider for the role APIs. The benefits of this pattern, however, are twofold. The existing guidance is widely available, and second, there is a lower cost per megabyte storage ratio when compared to SQL Azure. But let's look at another design pattern. This scenario is similar to the previous one, but uses the ASP.NET SQL membership provider and SQL role provider to implement authentication. So instead, in this scenario, we're authenticating to SQL Azure. And it also stores the user data in SQL Azure. It is primarily used by applications who have an existing solution based on ASP.NET membership system based on SQL Server and can then easily be migrated to the Azure platform. In this pattern, the user provides its credentials, and again, the same username and password over SSL to a web form, and the application uses the SQL membership provider to authenticate the user on SQL Azure. Access to the SQL database is done through a SQL connection string in the web.config that has a SQL username and password. Authentication then is done in the application logic using the SQL role provider for the role APIs. This pattern has a few more benefits over the previous design pattern. First, the existing guidance is widely available, and a large amount of product documentation and samples exist for SQL providers. Secondly, the SQL provider ships with the .NET framework, and they have been extensively tested. Another benefit is that the user data stored in SQL Azure can be relational, which really makes it more flexible for use in other functions beyond authentication. And lastly, there is no cost per transaction. Let's talk about two more design patterns. This next scenario demonstrates using an existing Active Directory user store with a Windows Azure hosted ASP.NET application. This solution is based on the WS Star protocol and uses Windows Identity Foundation for authentication. This pattern can be used in situations where you want to leverage an existing user hosted in Active Directory and you want to have a single sign-on with the Azure application. And it is okay to expose access to the store using HTTPS for the users that are on the internet. In this pattern, when the user connects to the Azure application, its browser is redirected to an ADFS version 2 identity provider that authenticates the user and provides the claims as a SAML token. The browser is then redirected back to the Azure application and delivers the token to the application, which then uses it to authenticate and authorize the user using the Windows Identity Foundation. To validate the token, a trust relationship needs to have been established between the Windows Identity Foundation and the ADFS provider, which typically involves providing the ADFS certificate to the application. So in essence, this pattern is claims-based where the other two patterns are not claim-based. And because this pattern is claim-based, this pattern also supports clients on the internet. Okay, let's wrap this up by taking a look at one more ASP.NET design pattern. This scenario extends the claim scenario by federating identity with a partner. The partner identity store is coordinated with the upcoming AppFabric Access Control Service 2.0 that is also running on the Windows Azure platform. So corporate users obtain authentication tokens from the federation provider and then have access to the different applications running on Windows Azure. You can use this pattern in situations where you want to externalize claim-based federation and authentication, which will use credentials from multiple user stores and from multiple partners. So this pattern is very similar to the previous one, but uses the AppFabric Access Control Service to establish the trust relationship between the identity providers and the application hosted in the Windows Azure platform. Users provide their claims to the Access Control Service, which then provides the claims to the Windows Identity Foundation-based applications. And because this is similar to the last claims-based design pattern, this also has support for clients on the internet as well.